Hey Astrophiles! In our last video, we embarked on a journey exploring the answer of a question, Twinkle, twinkle little star, how I wonder what you are. We began this by seeing how a star takes birth inside a nebula. Then, we saw it evolve into a protostar and then into a main sequence star. But, what happens to the star once it enters the main sequence phase? Stay with us till the end of this video and you will surely get the answer of your question. Main sequence stars are the most abundant species of stars in this universe. Estimates say that around 9 out of every 10 stars belongs to the main sequence family. They come in a variety of sizes like the tiny red dwarfs and the gigantic blue supergiants. It is the size of a star that decides how long it will remain in the main sequence phase. A larger star has more matter, and more matter requires more fuel. So a larger star would use up its nuclear fuel more quickly in comparison to the smaller one. Let us first go with the tiniest of the main sequence family, the red dwarfs. They could live for about 6 to 12 trillion years, which is even more than the age of our universe. So, none of the red dwarfs have been known to reach the end of its life cycle. But stellar models suggest that once they run out of their hydrogen fuel, they would become a white dwarf. These are incredibly dense objects, a teaspoon of which would equal the weight of an elephant. That's incredibly 5.5 tons in one single teaspoon. After an unimaginably large amount of time, tens or even hundreds of billions of years, white dwarfs cool to become black dwarfs, which are invisible because they emit at the same temperature as the cosmic microwave background. Let us know in the comments section if you want a detailed video on the cosmic microwave background. Now, let us take the example of the star closest to us, the Sun. Our Sun has been living for around 5 billion years and it will stay around for more 5 billion years, but once the nuclear fuel in its core gets exhausted, it would start fusing hydrogen in a spherical cell surrounding its core. This process would make the Sun grow thousands of times larger in size, making it a red giant. The red giant would swallow up the entire inner planets of our solar system, including Earth. But don't be afraid, we would have died a few billion years earlier. Now, where the red giant goes from here would depend on its size. The core of a sun-sized star would collapse into a white dwarf under the influence of gravity, and its outer layers would be expelled as planetary nebula. The larger stars could fuse even more heavier elements in a series of concentric cells. The diagram above depicts this in a more better way. Once the star has fused silicon to iron, it explodes with a bang into a supernova. These are one of the most violent phenomena in our universe. Yet, they are beautiful, isn't it? These blasts spread out much of the material produced in the red giant, including some heavy elements such as iron and carbon in our universe, which helps to make up both ourselves and our planets. So yes, it is true that we carry the remnants of the explosions in our bodies, and as Neil deGrasse Tyson puts in, it is quite literally true that we are stardust. The cycle starts all over again with a new generation of stars, and new stars are born from the stardust left behind in the same way. But that doesn't mean it's the end of the road for what remains of the star. After the supernova explosion, the star's core is left behind, about which we will know more in our next video. Till then, do watch the first part of this series where we explain the birth of a star in more detail. Do share this video with your friends, subscribe our YouTube channel Space Aura, and turn on the notification bell to always stay in touch with us.